Today we're going to change gear a little bit and talk about vacuum tubes or valves, as they are known in the UK. And what better example than the Fender guitar amp, Fender Champ, model 5F1, to get into tubes. I think this is a perfect example of a very simple circuit that involves tubes. And let's just go quickly over it. So here, this is the input, so that would be your input jack. Then you have that tube, the 12AX7. So this is like two tubes into one. So this happens to be a triad. Triad means that there are three elements to it. So this is the plate, the positive. This is the control grid, and this is the cathode, so that's the negative. And same thing on the other side. So this is basically a two-stage preamp. Basically what happens, it's very similar to a transistor preamp. The grid is like the base of a NPN transistor. This is like the collector, and this is like the emitter. So basically the input goes to the grid, and the output is at the plate, basically. So it's like the collector current. The plate current is like the collector current, and this becomes the input to the next one. Okay, so that's the two stages. This is the pot for the volume control. Yes, so on this amp there's no like treble tone control. There's no tone control, so it's only a volume control here. So this is like a voltage amp. This is to increase the voltage, because this is a very the voltage is very small. And then it goes into the power amplifier, which is here a single 6v6. So this is called a single-ended amplifier because there's only one. But if you had two in a push-pull configuration, that would be the double-ended. And there's not much to it. And the output at the plate is just going through like an output transformer, whose role is to basically match the impedance, because here you have high impedance on that side, and here you have low impedance. So that's your speaker at 4 ohms or 8 ohms. But today we're going to talk about this part, which is the basically the power supply, and more specifically the full wave rectifier here, that tube, that 5Y3, which has actually, it's like having two diodes in one package. So this is the plug, so this is your 110 volts, and that's your power transformer. So this is I don't know if you have ever opened a vintage tube amplifier, but that's the big giant piece of iron in the chassis. This is usually very heavy, and nowadays it's very expensive. So that's the important part in the circuit, really. So this is the primary. So that's your AC house current. So that's your 110 volts. And here you have a bunch of taps. A bunch of if you look at the power transformer, you will see that there are lots of wires coming out of it. So there are going to be two for the primary, usually black, and then they're going to be any number of output wires. So here, this pair here, this is AC, and this is 5 volts AC, and this is used exclusively to connect to the filament here, the double filament here, and this is basically the cathode of your two diodes. This is the high voltage. So here you have probably like 300 volts. I think it's 330 here, and you have another 330 here. So total 660 volts here. So this is AC and you're going to rectify it to get some DC. And the last, this pair here of output wires, that's going to be your filaments, or it should say heaters, 6.3 volts heaters. So those wires here, they carry quite a bit of current. So 1 to 2 amps, and same here. Those are smaller. They are smaller. The wires are smaller because the current is much less, like maybe 100 milliamps. So I think let's look into this full wave rectifier. Okay, so this is a simplified version of it, but here you have so in the 5F1, the two diodes are inside the same tube, but it's easier to explain if you have the two diodes completely separate. So here in the top one, this is the plate, and this is the cathode. This is the cathode, this is the plate. Okay, so you have the two diodes. This diode tube is equivalent to this thing, which you are probably much more familiar with. So a regular solid state diode. So this is the cathode, this is the anode, but it's basically the same thing. So you have one like this, and the other one goes the other way. Okay. All right. So now let's look at. Okay. So let's see how it works. So this is the input, the primary side. So let's say this is your AC, your 110 volts, and this is the positive part of the sine wave. So what happens to it on the other side? And here I'm going to assume that there's no phase inversion between the primary and the secondary. So here it's positive, so it means that on the secondary, the top is going to be positive, the bottom negative. And here you have a center tap, which is usually grounded, and on the 5F1 it is grounded. So it means that you have this ground, the potential depends on which one you're looking at. So if you look at this circuit here, this wire here on the secondary, it's negative with respect to the plus here. But if you look at this one, this wiring here on the bottom, the ground is actually positive with respect to the bottom. So we have to look at what happens in each wiring. So let's look at the top first. So the current goes to positive, it's going this way, and here this is the plate, this is the cathode, so it's gonna go through. The diode is conducting. Again, this is similar to this, so it goes through, and then here it cannot go here because this is the cathode of the other diode, so here it's blocking. So he has only one way out. He has to go through the load. So whatever is in the circuit has a load, and then it goes to ground, meaning that it has completed the circuit, because the ground, it's like connecting, it goes here and then goes there, like this. Okay. So if VRL is oriented this way, this is positive, and you get this. So now let's look at the other circuit, and you're going to see that the circuit does nothing. So this one, so the positive is here, so it means that the current is going this way. This is the same as this, so the current goes this way, and it cannot go anywhere because here you have the cathode. So it cannot go this way, it cannot go this way, so nothing happens here. So that's why you get this, only this. And here this is on the 5F1, for example, this is actually a step-up transformer. So if this is 110 volts, this is going to be on the 5F1, with the 5Y3, it's gonna be 330 volts. 330 volts, yeah. So now what happens when the it goes into the negative, the sine wave goes negative, what happens? Okay, so this is, now we are here. So meaning that you have the minus top plus bottom. So again, this is the ground. And so if you look at this wiring here, it's positive with respect to here. But if you look here, it's negative. It's always like that with the center tap. It's positive with respect to one and negative with respect to the other. So again, let's look at what happens in terms of where the current goes, what's conducting and what's not conducting. Okay, so I'm going to look at this one first. So current goes this way, it's the plate, so it's going to conduct. Here it cannot go there because you have the cathode, so it has to go through the load. Okay, and then it goes to the ground, and the ground is basically, the ground is the same as here. So it's like the current goes like this, then it's going back here. Okay, so like this through the diode. Okay, so and you get this. Again, it's the same sign as the other one because the current is going in the same direction. If you go back to the first one, the current is going this way, and this one the same thing, is going the same direction. So it's the same sign. So you get that second thing here on the output. So now we are looking at the other wiring, this one. So the plus is here, and that's the ground. So it is going, the current goes from here to here, then this way, and now he has no path. There's nothing. Everything it's blocked. Okay. So it's only this one that does something. I mean, if you have problems with this ground thing, what you can do instead, and maybe it's easier to see, I can draw it. Let me redraw the whole thing. Maybe it's easier to see. So you have the same exact thing. This is the primary, the core, secondary. So you have your two diodes. And what you can do is something like that. So you have your RL. And we know that this is ground and this is ground. So if you want, you can just pretend that it looks like this. Okay. So for instance, if we go back to the first one, so it was plus, minus, minus, plus. So plus, so it goes this way. Then it cannot go here, so it has to go this way. Goes this way, and it's basically coming back here. Okay, and then keeps going. So maybe this is easier to visualize. In any case, you end up with something that looks like this on the output. And there's always like a filter capacitor to smooth out the ride, if you will, because ideally you would want something like this, right? You want the DC. You don't want things that go like this. So you put a filter capacitor, and what's gonna happen is that the voltage is gonna, instead of going down, it's just gonna droop a little bit, and then it's gonna be picked up again. So it's basically the capacitor charging and then discharging, and then it picks up again. So it's like an impulse here, and then discharge, impulse, discharge. So you get something that's not this, but quite close to it. I mean, it's pretty, it's certainly smoother than this. But the only problem is that you only pick up half the voltage. You don't get the whole thing. That's what I'm trying to say. You're getting this voltage here, not the whole thing, not this. But for instance, if you had like if you had a bridge rectifier, you know, with the 4 diodes in a bridge configuration, then the voltage could be twice as high, because you don't need the center tap, you just have the whole thing. Okay, so this is a full wave rectifier, it's not a bridge, but it would be the exact same thing in solid state. So I think I'm going to stop here. If I go back to here, I'm not even going to go back to the computer. So we just talk about this part here. Oh, by the way, if you have never worked with tube stuff before, be very careful, because this is you have high voltage here. I mean, very high voltage. You have 330 here, so 660 volts total. So be very careful. Here you may be fooled because you have a power transformer. So it doesn't mean that you are safe because of this part. Be careful. Be very careful. It's a good idea to have an isolation transformer if you are gonna work on a tube amplifier. Isolation transformer here, so you plug this into an isolation transformer. Otherwise, you have to be careful. The neutral or the common, the white wire, which the white blade on the plug is connected to earth ground. Okay, so it means that here on this part of the circuit there's a earth ground, and if you touch this thing and you are, I mean, you have no shoes and you are in like 1 inch of water, if you touch, I mean, the juice is gonna go through you, so that's not good. So that's why you put an isolation transformer here, so that there's no earth ground there anymore. Okay. Yes, there's always a false sense of safety using a power transformer, because here actually this part of the circuit is quite safe because there's no earth ground. Okay. But this is the unsafe part. If you're working on like radios with no power transformer, like an All-American 5, this is where you have to be very careful, because here there's absolutely nowhere in the circuit that is safe. You need to have an isolation transformer. So be very careful. Educate yourself before working on the tube amps. And last but not least, when you are working on a tube chassis, whatever it is, never use both ends. Never probe with both ends. Always use one end only. Always put the other end somewhere else in your pocket. But yeah, be very careful, because if you use both ends, the current is gonna go through your chest, so that's not good. So again, I cannot stress that enough. Inform yourself about the dangers of working with tubes. Be very careful. If you are not sure, if you are tired, do not work on a tube circuit, please. All right. I'm gonna stop here. I think next time I will probably talk about like okay, so this is a triad. This is a triad. I'm going to talk about that the bias here, the cathode bias, because this is very. It's like the. It's like with a transistor. It's the same principle. Everything here is very similar to transistors. So if you know about transistors, you will have no problem with tubes. It's pretty much the same thing. So yeah, cathode bias, cathode bias. Because I think that's probably, and then at some point I'll probably talk about the output transformer maybe, and the impedance problem between this side and that side. Okay, we'll see. All right, see you around. Bye.